Probability discrete distribution. In this chapter, we're going to talk about probability discrete distribution. Random variable. We know random variable is a variable determined by chance, and we have two types of random variable. The discrete, which is countable or finite. For example, the number of pages in your book, the number of fingers in your hands. And we also have another type of a random variable, the continuous, which is uncountable or measurable, like speed, weight, or time. Now, only the discrete variable we can organize its probability in a table. So let's see in this example if our variable is discrete or continuous. The distance your car travels on a tank of gas, that's continuous. The number of students in a statistic class, this one is discrete. Now we mentioned that the discrete variable or the probability of a discrete variable can be organized in a table. So here we're tossing 3 coins. So first of all, let's find what is our sample space. So when we test the first coin, we're going to expect head or tail. When we toss the second coin, after the head, we're going to have head or tail, and after the tail, we're going to expect also head or tail. Also, when we toss the third coin, it's the same scenario. After the head, we're going to expect head or tail, and after the tail, we're going to expect head or tail. Therefore, our sample space is as such. Now, we're going to represent x by the number of heads, and we're going to find what is the probability of x. So 0 heads, that's or tail, and the probability of 0 heads, that's 1 over 8. 1 head, that's the probability of 1 head or having 1 head in our sample space, the 3 out of 8, and the probability of 2 heads, the 3 out of 8. The probability of 3 heads, that's 1 out of 8. Now this table we created is a probability distribution table, and the sum of all probabilities is 1. And don't forget our sample space. Now the sample space for tossing one die has 6 outcomes, and we're going to represent x by the number that appear on the face. Therefore, the probability of 1 is 1 out of 6, and the probability of 2 is 1 out of 6, and the probability of each number is going to be 1 out of 6. Therefore, this table we created is a probability distribution table, and the sum of all probabilities is 1. Now, medical test. The probability that a patient will have 0, 1, 2, 3 medical tests performed on entering a hospital are as such, respectively. So we have 6 out of 15, 5 out of 15, 3 out of 15, and 1 out of 15, respectively. We need to construct a probability distribution for the data. So the word respectively, it means the first probability goes for the first number, the second probability goes for the second number, and etc. Another distribution table where the sum of probabilities is all 1. So there's 2 components, very important. Each probability should be a number between 0 or 1. It can be 0 or 1 also. And the sum of all probabilities is 1. Having said that, let's determine whether each distribution is a probability distribution. If we look at A, each probability is between 0 and 1, and the sum of all probabilities is 1. Therefore, A is a probability distribution table. While B is not, because we have 2 probabilities, one exceeding 1 and one is negative. C, we have the sum of all probabilities is 1, and each probability is between 0 and 1. So C is a probability distribution table. D is not, because the sum of all probabilities is not equal to 1. And the last table, the sum of all probabilities is 1. We don't have any issue. So it represents a probability distribution table. In this example, we need to find the missing value. So we know the sum of all probabilities is 1. So we're going to add them and subtract. We're going to add all the probabilities we have and subtract them from 1. Therefore, the missing value is 0.3. Now, if we have a probability distribution table, we can find the mean and the standard deviation and the variance. We're going to use the calculator for that. So we're going to enter X in L1 and the probability in L2, and we're going to do one stat variable L1, L2. So we entered X in L1 and we're entering the probability in L2. Now we're going to go calculate one var stat L1, L2. Now our mean is 1.5, the standard deviation is 0.866, and the variance is the square of the standard deviation, and in our case here is 0.75. Another example where we need to find the mean, standard deviation, and the variance of the following table. So we're going to use the calculator. So we're going to enter the X in L1. And the probability in L2. Now we're going to do calculate one var stat L1, L2. Therefore, the mean is 1.23. The standard deviation is 0.646, rounded to 3 decimal places. And the variance is the square of the standard deviation, and in our case here is 0.4171. Now, expectation is another calculation of the mean, and it's so easy to calculate expectation. We only have to multiply X by the corresponding probability. So here we have the probability distribution table of rolling one die, and we need to find the expectation. So we're going to multiply 1 times 1.6 plus 2 times 1.6 plus 3 times 1.6 plus 4 times 1.6 plus 5 times 1.6 plus 6 times 1.6, and we're going to add them. Now we have another example of expectation. A person pays $2 to play a certain game by rolling a single die once. If 1 or 2 comes up, the person wins nothing. If, however, the player rolls 3, 4, 5, or 6, he or she wins the difference between the number rolled and 2. We need to find the expectation for this game, and is the game fair? So first of all, we know that if 1 or 2 appear, we win nothing. Keep in mind, this $2 that we're losing is the price of the ticket. So in each roll, we're losing $2. So that's the minus 2. That's where the minus 2 coming from. Now, 3 appears. 3 minus 2, that's 1. So we're winning 1. 4 minus 2, that's 2. We're winning 2. 5 minus 2, that's 3. And 6 minus 2, that's 4. Now we're going to multiply each winning by the probability. Then we're going to add them. Therefore, the expectation is negative 2 over 6 or negative 1 over 3. Now we lost because we got a negative expectation, so the game is not fair.